Hello, my dear students. From quite some time, I have been getting requests from the students to make some videos doing the test analysis of their school examinations in physics. So, I have decided to make a few videos on that, and the first paper which I have selected is the one which came as a monthly test in DPS Vasant Kunj. This paper was conducted in on 6th November uh, 2019, and I have selected two questions which I am going to discuss with you. They are very good questions, and this first question says that they have given a meter stick. Okay, so there is a meter stick given, half of which is made up of wood and half of which is made up of steel. Suppose it is pivoted at point O, and this is end is point A. A force is applied at the end A to rotate this. In the second case, again meter stick, wood and steel. It is pivoted at point A, and the same force is applied at point O. So they have asked that whether the angular acceleration in both the cases will be same or different. And if this angular acceleration is different, then in which case the angular acceleration will be more, and in which case it will be less. So let us call this case as case number 1 and this as case number 2. Now I find that because we know that torque is equal to force multiplied by perpendicular distance. In both the cases the force is same and the perpendicular distance is also 1 meter. So the torque produced in both the same cases is same. So it is constant in both the cases. But I find that if I compare the moment of inertia in the two cases, we know that, see, wood and steel are of equal length and area of cross section of both of them will also be same. So I can say that the volume of wood is equal to volume of steel. But since the density of steel is more as compared to density of wood, so the mass of steel, density of steel is more than the density of wood. So I can say that mass of steel is more than mass of wood. Definitely we can say this. Now in the case 1, we know that because it is pivoted at point O, so the more mass is concentrated at a larger distance as compared to this case. Because now we are rotating the stick about point A, and we find that more mass is located closer to the axis of rotation. So that is going to decrease the moment of inertia. So if I compare the moment of inertia of case 1 and case 2, the moment of inertia we know is depends on the distribution of mass. If larger mass is concentrated, more mass is concentrated at larger distance, the moment of inertia is going to increase. So the moment of inertia in case 1 is more than moment of inertia in case 2. Now we know that torque tau is equal to I into alpha, and we have said that torque is constant. So that means the product of I into alpha should remain same. Now if the moment of inertia is going to increase, the alpha is going to decrease. So as I1 is more than I2, so alpha 1 is less than alpha 2. So we can say that more angular acceleration will be produced in the second case as compared to the first case. So this is the first question which I have selected, and after that I am going to discuss the second question. So now after this I am going to discuss my second question with you. And before starting second question, I would like to tell you that if you want me to do paper analysis of the question paper of your school, you can mail it to me at the link which I am going to provide below. And also you can WhatsApp me at my number, which again I am going to provide you in the description box of this video. And moreover, I am also providing Skype sessions for one-to-one discussion. If you want that, I will also provide a link for my Skype session also in the description box. So the second question which I'm going to discuss with you is again a very good question. It says that there are two stars of mass 16m, there are two stars of mass 16m and mass small m having a radius of 2a and a. Suppose they are located at point A and B. They are separated from each other by a distance 10a. Okay, they say that a mass small m is fired from the surface of the first star A. Then what should be the minimum initial speed to be given to this mass small m so that it reaches the surface of mass capital M? Now this is a very good question of gravitation, and I have selected to solve this question. The basic concept of this question is that we need energy to reach at one particular point P, somewhere between these two stars, where the gravitational force on mass small m due to both the stars should cancel each other. Suppose there is a point P where now the small m has reached and A is applying a force Fa, B is applying a force Fb, and both the forces are equal to each other. So the net force on mass small m will be 0 at this particular point. After this, when small m moves towards B, the gravitational pull of capital M is going to pull this mass small m towards itself by its own. Okay, we need energy to reach at point P only. So I need to find the position of point P. So let the point P is at a distance x from the center of B. So the distance of point P from the center of A is 10 minus x. And as we have said that Fa should be equal to Fb, so at this particular point P, the force Fa should be equal to the force Fb. The magnitude of the force Fa will be equal to G into 16m into small m divided by 10a minus x whole square. So this is basically 10a distance, 10a minus x whole square should be equal to Fb. Fb is G into capital M into small m divided by x square. Okay, so this G gets cancelled out, small m gets cancelled out, capital M gets cancelled out. So we get 16 divided by 10a minus x whole square is equal to 1 upon x square. Now what we can do is we can take square root on both the sides. We get 4 divided by 10a minus x is equal to 1 upon x, or we get 4x is equal to 10a minus x, which implies that 4x plus x is 5x is equal to 10a, or x is equal to 2a. That means point P is located at a distance 2a from capital M, and it is located at a distance of 10a minus 2a means 8a from the center of mass 16m. Now, what is the initial potential energy of this small m when it is located on the surface of A? Let us find out. The initial potential energy of mass small m with respect to both the planets, with respect to both the stars, when it is located on the surface of mass 16m is the potential energy due to 16m. Potential energy is minus gm1 m2 upon r. So it will give you minus g into 16m into small m divided by 2a minus, and potential energy due to capital M will be minus g into capital M into small m divided by, now the distance of this small m from the center of capital M will be how much? This is 10a, this is 2a. So 10a minus 2a is 8a. gmm upon 8a. This is the initial potential energy when small m is present on the surface of 16m. Now let us work out the gravitational potential energy of mass small m with respect to both the stars when it is at point P. Let us call it UF, the final potential energy when it reaches at point P. With respect to both the stars will be equal to, the potential energy due to 16m is minus g into 16m into small m divided by, now this distance we have calculated as 8a. This is 8a minus g into capital M into small m divided by, now this distance we have calculated as 2a. So this is the final potential energy. Now let us find what is the change in potential energy when it moves from the surface of this 16m to point P. That change in potential energy will be delta U. So let us calculate this change in potential energy over here. The change in potential energy delta U will be equal to final potential energy minus initial potential energy, which is equal to minus, this is equal to minus G into 16m into small m divided by 8a minus G into capital M into small m divided by 2a minus minus plus G into 16m into small m divided by 2a plus G into capital M into small m divided by 8a. So this is equal to, now we can take 8a as our LCM. So that will give us minus G into 16m into small m minus 4G capital M into small m plus 2 4s are 4, 16 4s are 64 plus 64 G into capital M into small m plus G into capital M into small m. Okay. So this is equal to, so this will give you the change in potential energy. 64 plus 1 65 and this 16 plus 4 20. 65 minus 20 is 45. 45 by 8 into G into capital M into small m by A. This is the change in potential energy. Now when the object is moving from this surface towards point P, this change in potential energy, which is positive, means there is a gain in the potential energy, is due to the kinetic energy given to this mass on the surface. Now this is the key concept. The kinetic energy which I have given to this object on the surface, half mv square, results in the gain in the potential energy. So we are applying the conservation of energy in this case. So half mv square is equal to 45 by 8 into G into capital M into small m divided by 8a. So we are going to solve this question. So mm gets cancelled and mm gets cancelled. So 2 4s are 8. So this 4, this is 40, not 48, this is 45. So v square is equal to 45, or we can take square root of this. So that is going to give you 3 by 2 into under root of G into capital M 4 5 under root G into capital M by A. V is equal to 3 by 2 under root 5 G M by A meter per second as your answer to this problem. Okay, it has gone a bit below the calculation, so I'm going to write it here. So V will be equal to 3 by 2 under root 5 G M by A meter per second. Because it's under root 45, 5 9s are 45. So 9 goes out of the square root and comes out as 3. So this is our answer to this problem. So you can see this was a 3 marks question, I think, and was quite challenging for school examination.